Within EuroGO-SHIP, it was GeoMass deliverable to develop methods to produce and distribute in-house reference material. The procedure is closely following procedures developed at Scripps Institution of Oceanography, USA. These in-house reference materials will be used to check stable conditions during laboratory analysis, but also for calibrating and validating sensors and instruments during research campaigns. For the ship installation to collect seawater for use as a substandard in marine carbon measurements, 3 filter housings containing polypropylene filter bags, 25 micrometer, 5 micrometer and 1 micrometer in pore size, were attached in series to an IBC container. The filter housings were connected by hoses, allowing seawater to pass through the filters in order of decreasing pore size. After passing through the final filter, the seawater flows through a UV lamp connected via hoses to both the last filter and the inlet of the IBC container. The hose connected to the first filter housing is at its other end connected to a valve that regulates the water flow. Another hose is connected to the other end of the valve, leading to a submersible pump. Summarized, the seawater is pumped by the submersible pump through the hose and valve into the first filter housing, then through all the 3 filters. It then passes through the UV lamp for sterilization before entering the IBC container. For the lab installation, depending on filtration feasibility during collection or the required storage time, the filtration unit can alternatively be connected to the seawater tank in the laboratory. Prior to filling the substandards, the seawater is pumped through the UV lamp and optionally through the filters, continuously for at least 72 hours, serves to homogenize the water. To homogenize the water, it is circulated using a bilge pump. The seawater is pumped out of the seawater tank, passed through the filters and UV lamp, and returned to the tank. Ambient air is introduced to the container to provide a fairly constant atmosphere above the water. To provide a constant atmosphere above the water, a pump providing clean atmospheric air at a flow rate of approximately 50 ml per minute was connected. Alternatively, a gas bottle with a constant CO2 content, similar to atmospheric CO2, can be connected. On the sampling day, the bilge pump is removed and a seabird thermosalinograph is submerged in the tank to measure salinity. Of course, any other sensor for measuring salinity can be used as well. Additionally, a peristaltic pump is installed for the actual sampling. For sampling, the peristaltic pump is activated using a foot pedal, and the seawater is carefully pumped through a hose into Durand glass bottles that have been pre-cleaned and pre-combusted at approximately 450 degrees overnight. Bottles are filled with a small headspace left at the top. Following the SOP of Dixon et al. 2007, the tubing is placed in the bottom corner of the bottle to minimize the introduction of air bubbles during filling. After filling, the hose is carefully removed and the bottle is sealed immediately with a pre-greased ground glass stopper. The grease on the stopper's ground joint ensures an airtight seal to prevent atmospheric gas exchange. The stopper is additionally secured with a tightened rubber loop and a clamp. As an alternative to glass bottles, filling seawater into plastic bags is currently being tested. For this, the valve of the plastic bag is removed and the filling hose is inserted to the bottom of the bag. The peristaltic pump is then started with the foot pedal to fill the bag with seawater. Once the plastic bag is full, the valve is reattached as quickly as possible to minimize the air exposure.